Hello everyone. I would like to welcome you once again on our Cambium College. And today our topic for Cambium College is IP Internet Protocol version 6 and its configuration. My name is Dmitry Moiseev and I'm an engineer here at Cambium. And I would like to make an overview of the IPv6 and its implementation in the Cambium hardware. So let's move forward. So what is the agenda for today's Cambium College? First of all, I want to make brief recall what is IPv4 and why we need the new internet protocol with the version 6. So why we are looking for something different. Then I will make an overview about the IPv6 and the new IPv6 features that are different from the IPv4 that we traditionally get used to the IPv4 protocol. And at the end, I will cover some configuration examples you can do with the IPv6 with the Cambium gear. To give you the idea what you can do. The whole idea for this Cambium College is not to give you all the information about IPv6 because it's a really huge topic. There are lots of bits and pieces of information and it's a pretty deep topic. So today it will be just an overview. But it will give you the hints, and if you are interested in some specific topics you can go and search for them deeper. Okay, so let's start with the IPv4. So what is IPv4? It is like standard de facto right now in the internet. Actually, IP means internet protocol, so internet is built on top of IPv4. And what v4 means, actually it is version number 4, meaning that it was the IP version 1, version 2, version 3, but it was long time ago. So the early versions of IPv4 was in the early 80s. Initially it was deployed by a small subset of universities in the United States, and some government structures then added to their IPv4. So it was never built and designed to work at the scale of the current internet. I think nobody who developed IPv4 ever dreamed that it can be that hugely deployed as IPv4 nowadays. So what makes it good and bad nowadays? So first of all, it's a standard. All the devices nowadays support internet protocol. All hardware, all software stacks, they support IPv4. But the main issue with the IPv4 is the address space, because the amount of addresses you can use in the IPv4, it is really limited comparing to the amount of devices in the internet. And we are moving from the traditional era to the Internet of Things era. And it will be more and more devices connected to the internet. So we are lacking of address space. Other issue that IPv4 is lacking some of very important features. So the first feature is multicast. Right now it is implemented. There are multiple supporting protocols like IGMP. There are multiple versions of IGMP, and even different vendors, they can implement their own networking vendors. They can implement different IGMP versions and features. For example, IGMP fast leave, which is kind of a non-standard feature. And another feature which was actually backported from the IPv6, it is IPsec, used for additional security in the IPv4. Initially, when IPv4 was developed, nobody thought about the network threats, hackers, and network security at the same scale as we think nowadays. So IPv6 initially was developed with the IPsec, with the additional encryption, which was then backported to the IPv4. Other things that makes everything a little bit more complicated is all those tricks to save the address space. So the first one is the classless inter-domain routing CIDR, which makes routing and routing protocols, I can say that they are making them complicated, but for routers to implement those routing algorithms, it is pretty complicated, and it's CPU intense, and all the routing fabrics, they should be tuned to work with it. And another feature is network address translation, which is also CPU intense. So router have to do all the tracking of the networking flows coming through the router. And all those things are to solve the issue of depletion of the address space. So how bad it is nowadays? I took this screenshot from the RIPE website, and it is showing us the current IPv4 pool during last 3 years. As you can see, it is decreasing, and every other year we hear that we don't have any more IPv6 v4 addresses left. In fact, we have the last subnet, which is available for allocation from RIPE. They are not giving IP addresses left and right as they used to 10 or 20 years ago. There is still some pool from the addresses that were returned by some reason by the previous resource holders because of the companies going bankrupt, not using IP addresses, not paying fees for IP addresses. So there is some pool available, but still the amount of IPv4 addresses is getting less and less every other month. I don't want to try to see the future and get any approximation when we will not have any IPv4 addresses, but it will be some near future. So just quick overview and recall what's the IPv4 address format. So it is 4 bytes. So 1 byte is 8 bits, and making it 32 bits of the IPv4 address. Some part of it used for the network, part of it, another part of the IP address used for the host address. So how IPv6 helps us in this case? So let's switch to our main topic, which is IPv6. So IPv6, we typically think about IPv6 as it's a new protocol. But as I said in the very beginning, and I have it on the very first slide my presentation, that it is the old protocol to build the future networks. It was actually formalized in the 1998. So it will be more than 20 years ago next year. Meaning that it's relatively old protocol, but since 1998, it is still not become a standard in the internet. The main reason why we are not using IPv6 widely nowadays, because it doesn't provide backwards compatibility, and I will try to cover it. But first, let's focus on the features of IPv6, what it gives us. So the first feature, the main feature of the IPv6 is the larger address space. We have 128 bits of address used in the IPv6. The next feature, it is simplified header. First of all, it was simplified for the networking equipment, so it can forward IPv6 packets quicker and read, filter, and work with the IPv6 headers better and more efficient. Other thing is the end-to-end connectivity, meaning that we don't need any network address translation to connect all the devices, because any device can have its own unique IPv6 address. Other thing is auto configuration. You don't need any additional DHCP server or any other mean of auto configuration. It was developed with the security in mind, so IPsec is the core part of the whole standard. There is no concept of the broadcast, which was causing lots of issues with the IPv4, like broadcast storms and stuff like this. So there is no concept of the broadcast, but the multicast is built in as a part of the IP protocol, meaning that you don't need IGMP and other additional protocols with the different versions of it to have multicast working in your IPv6 network. There is also something called Anycast. I will cover it later on. It is working really nice with the quality of servers. There are some nice features added to the IPv6 to support better quality of servers and better up-to-date quality of servers features comparing to the IPv4. IPv6 provides smooth transition from the IPv4. Yes, it is not backwards compatible, but there are nice transition paths how you can transition from IPv4 to IPv6. And it is very extensibility of the protocol is very high, so you can create extensions for your custom protocols built on top of the IPv6 very easy. So the larger address space, as I said, IPv6 using 128 bit addresses, which is 4 times comparing to IPv4. The only downside of it that you have to write down all those bytes, and to make our life easier, there is a standard way. So if there are lots of zeros in the IPv6 address, you can omit them and use 2 colons inside instead of those zeros. So there is an example how it works. The good thing is that in most cases you don't really have to remember all those IPv6 addresses. They are meant to be used by machines, by devices, not by human beings. And everything about this IPv6 was made the way that you don't really have to remember all those numbers. So this simplified header of the IP packets. As you can see, multiple fields, they were just removed, and it made really clear header with a fixed size, which is really easy and quick to work for the hardware. So it's easier to create hardware to work with these headers. And again, you don't have to manually work with the IPv6 headers by yourself. Everything is up to routers in your network. So fields like header checksums, options, paddings, fragmentation was removed out of IPv6 headers to the different layer. So there is encapsulation layer. So if you have fragments, there is fragments encapsulated into the IPv6. What was added to the IPv6 header comparing to the v4 is the flow label. So your application can tag those IPv6 flows with a certain label, and then it can be used again by the routers, by the firewalls, and other networking equipment to detect specific application flows, no matter on the payload of those packets. Other thing is the new concept. Instead of type of service, we have traffic class, and the IPv6 introducing new concept for the quality of service. The next header field shows the type of the encapsulated data inside the IPv6 packet. What other features we have in the IPv6 that can be beneficial for us? So usually when we hear about IPv6, we hear it together with the Internet of Things buzzword. Because in the world of Internet of Things, we have lots of devices, coffee machines, fridges, different sensors, everything connected to the internet. So to make it easier to connect, we can give unique IP address to each and every device in the network in the world. And you don't need any network address translation. You don't need any network address translation algorithms. So if you have some application working, you don't have to think how you will traverse over the network address translation to get your multiple sensors connected to the mesh kind of topology, for example. So it really helps that you don't have to deal with network address translation. And on the IPv6 on this slide, you can see that there is a joke that you can assign an IPv6 address to every atom on the surface of Earth. Actually, if you try to calculate, I can say that it's really hard to calculate the amount of atoms on the surface of Earth, but still it will be less than the amount of IPv6 addresses available. So if you make all of them sensors or Internet of Things, you can assign the unique address to each of them. Other thing is the auto configuration. With the IPv4 right now, for auto configuration, you have to use DHCP. With the IPv6, You can still use DHCP v6 to make the so-called stateful IPv6 configuration, but the typical way that you don't really have to do this. You can use so-called neighbor discovery protocol. So devices will negotiate automatically the IPv6 addresses to be used. Another benefit, as I said, simplified header makes routing faster, and you can see it from the benchmarks for different networking equipment, that sometimes it's way faster to route IPv6 comparing to IPv4, especially in some complicated configurations. And security is a part of standard. So again, in the world of Internet of Things, all those internet connected devices can encrypt all the data communications between each other, and it is a part of standard. In the IPv6, there is no concept of the broadcast. So if you want to send the broadcast message to the whole network, there are some special multicast groups you can use, which will act similar to the broadcast. But in order to receive those broadcast messages, you still have to sign to a specific multicast group. So it acts similar to broadcast, but it is not a real broadcast. There are multiple addressing, so you can do multiple unicast addressing. So the first one is the global. You can think about global unicast addressing in the IPv4 the same way as you think about in the IPv6, the same as you think about your global addresses, global routed addresses in the current internet, in the IPv4 internet. So the link local addresses, it's a special IPv6 addresses that are used between two connected, like physically connected to each other devices. So if you have a router and your laptop and they are somehow connected through the Ethernet or through the Wi-Fi, they can use these link local addresses to commute to each other. Those addresses starts with the FE80 address. There are also unique local addresses. You can think about those IPv6 addresses as the local addresses in the IPv4, local network addresses like 172 or 10 something. And there is also loopback, which is similar to the IPv4 loopback addressing. So multicast, as I said, it's a part of the standard. So again, there is no different versions of IGMP, and you don't have to mix and match all the different equipment to support the same version and the same flavor of IGMP. And there is so-called anycast addressing. So for anycast, it is similar to unicast in some things, but with anycast addressing, you can have multiple, for example, servers in your network having the same anycast address. And if your CCTV camera, sending the data to this anycast server, it will be routed to the closest anycast server in your network. So this is the special anycast addressing which were absent in the IPv4. So what are the issues with the IPv6? Why we still don't use the IPv6 that was introduced and formalized 19 years ago. The main reason that it is not backwards compatible. There are three different migration paths. If you want to use IPv6 and you have IPv6 router, it can directly talk to the IPv4 client, for example. So the first way to do this is to implement so-called dual stack. Dual stack for the IPv6 router, meaning that you have both IPv4 stack and IPv6 stack running on the same hardware. So if you have IPv6 clients or IPv4 clients, you use specific appropriate stack in this case. There is a way to do tunneling. So if you have two routers and between them is the only IPv6 network, you can tunnel inside this IPv6 network IPv4 client's data. And the third way to migrate somehow is to use different network address translation between IPv4 to IPv6 and from IPv6 to IPv4. Usually both ways are supported by different hardware. But it's causing lots of issues and lots of complications in the configuration. Another thing, I really like this website. It is called IPv6excuses.com. It generates the IPv6 excuse bingo. So if you have any kind of discussion about IPv6, you can use this IPv6 excuse bingo and see what arguments are against the IPv6 migration. There are tons of them. First of all, it's too complicated. It is the number one excuse I usually hear about IPv6. There are other arguments. Some of them are relevant. For example, some functions of AWS from Amazon doesn't support IPv6. Azure, not all services in the cloud supports IPv6. But on the other side, IPv6 is the internet standard. It is very, very mature nowadays. There is clear migration path for the IPv6. So if you are not looking for excuses, but you're looking for the way to migrate and use all the power of IPv6, you can always find the way to do this. So how bad IPv6 adoption are nowadays? This screenshot is from Google. So this is the amount of IPv6 traffic coming to Google. The amount of clients going to google.com and their services using the IPv6. As you can see, it's growing, and it's growing faster than linear progression. So right now, about 20% of Google customers using IPv6. You can go to the Google IPv6 website and see different regions and different providers, how they support IPv6. But the general population who is actually using IPv6 and they don't know about it are mobile clients. So mobile operators, especially in the United States and in some Asian countries like India, they deploy widely IPv6. And when you go to google.com on your iPhone, you don't even know that it is using IPv6, but in fact it is. So this is why we have like 20% of 20% of IPv6 usage for the Google. So what is the future of IPv6? So most of the IPv4 resources are allocated for United States companies and for companies based in Europe. So if you're unlucky enough to have your company somewhere in other parts of the world, it's really hard to get IPv4 allocation for you, even if you're an operator. This is why many countries and many governments, especially China, India, and other countries with a large population and with very few IPv4 allocation address space, look into the IPv6 migration. And in most cases, um, regulatory requires operators to use IPv6. So if you want to run your business in India or in China, you most probably have to follow regulatory requirements to have IPv6 connectivity for your customers. Right now, let me give you the example how Cambium networks with our equipment, because we are at the end of the day network equipment vendor, what we do with the IPv6. So first of all, in most cases, we are transparent to all the IPv6 data. We provide a pipe, backhaul, fixed broadband wireless access to the customer's Wi-Fi. So we provide connectivity. And in those cases, we are transparent to all the IPv6 data. On some of our units, especially on the ePMP and CN Pilot Wi-Fi routers R series, which are the home routers, we support IPv6 management. So you can manage your ePMP or CN pilots using the IPv6 addresses. On the CN Pilot R series, we also support the DHCP server for the IPv6 and actually network address translation for the IPv6. On the PMP 450, we have quality of service and filtering for the IPv6 packets. So you can filter, create firewall rules or QoS rules for the IPv6 data. So how it looks like. Configuration of the IPv6 on ePMP, for example, is relatively simple. It's very similar to the one you have for the IPv4. So you can choose the static configuration or DHCP-v6 configuration. After this, if you have DHCP-v6 server in your network, you can start managing device through the IPv6 address space. So CN Pilot R series. On CN Pilot R series, we have multiple settings for the address, for the internet, for WAN interface setting. So you can set up the stateless or stateful address. Stateless means that the device will use neighbor discovery protocol to figure out the address to use with its upstream router, and stateful means it will use DHCP-v6. And on the other side, you can create the IPv6 DHCP-v6 address pool for the LAN side to connect clients on the client side. And this one is the example of the packet filter you can create for the IPv6. There are multiple options like all IPv6, or you can filter SNMP or DHCP bootp client server packets or IPv6 multicast. So you can create multiple IPv6 rules to filter out IPv6 packets. So that's about it. And here I have multiple questions, FAQs. So what happened with the IPv5? We had IPv4 and right now we have IPv6. So what happened with the IPv5? Actually, it was a real protocol which was called IPv5. It was used for different experiments. It was long time ago, exactly in the meantime between IPv4 and IPv6. And and finally it evolved in the IPv6, which was formalized as an official standard. And another thing, we don't have to care. We can buy more IPv4 addresses. Again, it's a matter of time, and the time is running out until you can buy those IPv4 addresses. If you can buy them now, that's probably it's a good idea to buy them. So IPv4 v6 is our future, no matter if we want it or not. So if you have any questions about IPv6, please feel free to ask, and I will be more than happy to answer. Okay, for now I don't see any questions from online audience. So I would like to invite you to Wispapalooza in Las Vegas on the second week of October to see our new products. We'll bring lots of exciting stuff to the show to present. So please feel free to stop by. We will be more than happy to see you there. And please go to our community forum, check our other Cambium College recordings. And if you have any questions, please feel free to post them on the community forum. And me and other engineers will be more than happy to answer all your questions. And if you have any idea of the feature we should implement or anything you want to see in Cambium, please feel free to post it to the ideas section. So thank you for your time. I hope it was useful and I gave you the IPv6 overview. Okay.